So pipeline network modeling in PipeSim. PipeSim is considered one of the standard software for one of the industry standard software for network modeling in the market today. Okay, it has unique network modeling capabilities, such as it has both the logical network canvas. So this is what we call the logical network canvas. All right, in which basically you see the walls connected into junctions and then the pipelines, or you have the GIS, GIS, which is Graphical Information System Network Canvas. So this is another display of the network, okay? And you can switch back and forth between the two canvases, all right? And in the network, in the GIS network canvas, you can look into the well locations, you can look into the results gradient, etc. You can have automatic network model building using the GIS shape files. So when I am in the GIS canvas, I can import what I call shape file. The shape file is nothing but a 2D representation of this flow line, okay, that is normally generated by the mapping services in any company. So in any company, if they want to, they usually have a GIS or mapping services or mapping unit or a division to do mapping for all their flow lines, trunk lines, pipelines, etc. Okay, and these pipelines usually are composed or are saved as what they call shape files. It's a layer of basically lines and connections with when it has information of the pipeline networks. If you have the shape file, it is .shp. Okay, SHP stands for the shape file. If you have the pipeline shapefile in your company, you can easily import that into PipeSim and you can build your pipeline network automatically. And I will demonstrate this today. You can also build your network automatically using Python scripting. All right. If you have the data stored in Excel or in any other means, any database, you can develop a pipeline, a Python script to automatically build your wells and network models, build all the connections, even run the simulation without opening the user interface. All that can be done using Python scripting. And we have integrated wells and pipeline pipeline networks in a single model. Okay. Many available other software in the market, you will need to model the wells in a separate software, save it in a separate file, and then model the network in another software, and then import the data for the wells, okay, for each well from the other software, and then you need to generate what is called VLP, vertical lift performance, or outflow curves, to model the wells. In PipeSim, we have integrated wells and network models, okay, in the same file, and the file is not big in terms of size, okay. So you can easily double-click on a well icon, and then you will open the well data. You can change the well data. You can even run the simulation for that well while you are in the same network model, okay. And then we have a separate production optimization service. What we have is that we have the network simulation, which is the model itself with all its configurations based on the current operational data. And then you can run an optimization service on top of that. This optimization service, while it's running, it will show you, it will give you the recommendation for new field settings, such as the choke settings, distribution of artificial lift, etc., and without touching the network simulation itself. And then if you are happy with the recommendations that the optimizer will give you, you can then send these recommendations back to the network simulation model. So talking more about the network optimizer in PipeSim. PipeSim Network Optimizer also has unique capabilities. Number one, we have what we call accurate and smart well curve generation. Maybe this is a bit of advanced to most of the audience here, but let me just quickly describe what we're talking about here. For the network optimization, in order for the simulator to find the optimum settings, it actually needs to run maybe 50, 60, or maybe 100 network simulation settings to find the optimum. And for that, it generates what we call will curves. So the will curves are basically predefined conditions, or oil production versus, let's say, choke size. So the simulator, before running the optimization, will go and create this curve for this well. And then when it runs the network optimization, it will start, just playing with these will curves until it finds the optimum combinations. And then when you publish these new settings, the new choke size into the network, then you are going to run the network simulation again completely from the sand phase. We can have runtime choke bean size calculation. So this is what I just showed you. So it tells you the required or the optimum choke bean size, right? The recommended choke bean size in order for you to maximize oil, maximize gas, or honor your constraints, for example. Okay, and then you can publish back to the network simulation. You can honor total system gas lift rate and or total system power for ESP and PCP. You can specify what is the total artificial quantity, and then it will distribute the quantity among the wells. You have the concept of optimization studies. You can modify boundary conditions and phase ratios for testing different scenarios. And then this is what I mentioned many times, review and publish the optimization results to the operational network automatically by clicking on publish optimization results back. We have 4 well control optimization variables. So the optimizer can tell you what is the recommended choke bean size automatically. It can tell you the recommended gas lift rate automatically, all right? The ESP frequency and the PCP speed. So suppose that you have, for example, 50 or 60 wells, and these wells are operated using gas lift, okay? So each well is modeled separately, and then let's say each well has, for example, 1.5 million standard cubic feet of injected gas. Another well has 2, another well has 0.5, etc. Okay, but then you need to optimize your production. You need to maximize your production and reduce your distributed gas lift rate. So you go to the optimizer and run it with the constraints. You put constraints. You say, okay, I want to maximize liquid rate. This is my maximum gas injection rate that I have. Show me how do I distribute the gas lift rate among the wells. So the optimizer will run. It will give you new recommended gas lift rate for each well. And then you can, with a push of button, you can send these gas lift rates to the wells. And then you can run your optimized case in the network. These are the constraints. So we can define, for example, min or maximum Q liquid or liquid rate for the wells. We can put the maximum liquid rate on flow lines, sinks, global constraints, etc. Maximum GOR, maximum erosion and velocity ratio, maximum CO2 and H2S on the pipelines, etc. Or globally on the whole field.